The back cut is also often commonly called the felling cut. Its vertical location is determined by the location of the notch and the height needed for the hinge. That information will be discussed in the video on engineering principles of the hinge. For the moment, we'll concern ourselves with the back cuts, looking at simplest to most complex. In the ideal case, the back cut is a simple horizontal cut that ends at the hinge. In other circumstances, the back cut may have to accommodate the use of felling wedges and may need to be made in several discrete steps. In the simple case, the cut should be made roughly perpendicular to the axis of the trunk, as that is the most efficient orientation. There is no legitimate reason to use a different angle, as the wood above and below the cut no longer influences the felling process. In the event that a wedge must be driven into the back cut to bring the tree down, an inclined back cut runs the risk of splitting out the acute side of the cut. Two factors are critical in choosing an appropriate design for the back cut. First is the lean of the tree relative to the direction you want it to fall. Second is the extent to which you will be able to use rope, cable, or chain to pull the tree down. These issues will be discussed further in the videos Pulling the Tree Down. Looking at the first factor, we can consider four categories. If the tree has a slight lean in the desired direction of fall, it can be successfully felled without the use of either a wedge or a rope. Only cutting a notch and a simple back cut are needed. If the tree has a pronounced lean in the desired direction of fall, no rope or wedge are needed, but the felling is dangerous and needs careful technique to avoid potential disaster. The proper technique is covered in the video Leaners. When a tree is leaning away from the desired direction of fall, that is termed back lean. If the back lean is slight, wedges should be used in the back cut to force the lean to reverse and cause the tree to fall in the desired direction. If the situation is favorable to their use, ropes may be used to help pull the tree in the desired direction. However, it can be very risky to rely on just pulling to overcome the force exerted by the tree. It is very easy to underestimate the force that the tree exerts, and very easy to overestimate the force that the pull can produce. To play it safe, a back leaner should never be hand pulled except in conjunction with the use of wedges. If the back lean is pronounced, wedging will not help much, and strong mechanical means will be needed to pull the tree back up to vertical and to then control it in the desired direction of fall. The issues involved are quite tricky and are covered in the video Back Leaners. The complex back cuts, then, are associated with those cases where the tree has a mild adverse lean, and the back cut will have to accommodate a wedge and the driving of that wedge to fell the tree. Interestingly, the complexity of the back cuts increases as the diameter of the tree decreases. So, we will look first at the simple case, which is with a large diameter tree. With a large diameter tree, the back cut can be well started and wedges placed while there is still plenty of uncut width to keep the tree in place. The wedges should be plastic rather than steel, as severe damage can be done if the chainsaw makes contact with the metal. Plastic wedges are available from a number of sources at prices ranging from $5 to $20. These wedges are soft enough to not damage the chain, but are therefore easy to damage when vigorously pounding them into the back cut. To prolong the life of the wedges and make driving them easier, 2, 3, or 4 should be used if the space is available. 4 wedges exerting 1,000 pounds of uplift each can be driven much more easily than one being squeezed with 4,000 pounds of compression. WorkSafe BC, that's British Columbia in Canada, has produced an excellent series of videos on safe timber felling. They advocate that cutters take a minimum of 3 wedges with them into the woods. That is appropriate considering the large trees they are often felling. Moving down to smaller, medium-diameter trees having mild back leans, it will be desirable to keep the notch cut shallow to allow as much room as possible for the saw and wedge in the back cut. For practical purposes, a tree is no longer considered large if the width of the saw and the wedge can't be safely included in the same cut. The situation may be considered unsafe if essentially the entire back cut must be made before there is room to insert the wedge next to the blade. If the back cut is essentially completed before the wedge is inserted, there is a good chance of the tree settling back and locking down on the saw blade. With the kerf closed, it may not be possible to insert the wedge to free the saw. In the worst case, rather than just settling back, the hinge could snap and the tree could fall the wrong direction. Below the critical diameter, some sequencing will have to be used, which permits the wedge to be placed in the back cut after the saw is removed. One such sequencing is illustrated here. First, a plunge cut is made through the tree. Cut the hinge to its final width at this point. Second, remove just over half of the back strap. It won't matter if you take out some of the middle of the hinge, just as long as the ends remain intact. Third, insert a wedge into the back cut. Try to leave around an inch of space between the wedge and the remaining back strap. This will reduce the chance of sawing into the wedge when you cut through the rest of the back strap. Since the back cut can't open up at this point, you should not be hammering hard on the wedge. Merely drive it in enough so that it won't fall out. Fourth, insert the saw through the opposite end of the plunge cut and finish cutting through the back strap. Again, as long as you don't cut into the ends of the hinge, it is acceptable to use the middle of the hinge as a pivot point to help push the saw through the back strap. Finally, drive the wedge in to topple the tree. If the wedging is tough, add a second wedge. With a small enough diameter, you will get to a point where it will be difficult to get a plunge cut parallel to the hinge. For such a small diameter back leaner, one approach is to use 2 stacked diagonal plunge cuts to accomplish the back cutting. In this approach, the first cut is a plunge cut that goes in about 1 to 2 inches above the bottom of the notch apex. This cut should daylight through the middle of the hinge. Next, square the corners of the plunge cut to finish the hinge width on that side and to remove enough of the back strap to get a bit past its middle. Then insert a felling wedge, making sure it is aimed into the slot cut into the top of the notch. Next, make a second plunge cut starting approximately 1 inch below the first and on the opposite side of the back strap. Square the corners of the plunge cut as before. Looking in plan, much of these 2 cuts will overlap. It is critical that they overlap a little bit at the back of the back cut. When the wedges are driven in, a vertical crack will develop within the overlapped area, and the tree will be free to rotate towards the notch, pivoting on the edges of the hinge. If one wedge can't induce enough lean, one of the 2 wedges can be withdrawn slightly so that a third wedge can be placed on top of it, doubling the angle of lean that the pair can impart. In the next video, Engineering Principles of the Hinge, We will see why those cuts are acceptable.